guys, this is the last section that we need to go over before your test, which is next Monday. Do not be surprised when you come in here next Monday that you have a test. It's going to be over 7475, 82, and 83. I will give back the 7475 quizzes before the weekend. I just have a bunch of makeups that have to get done before then. The makeups are either today after school, Tuesday or Thursday, morning with Miss Glick, afternoon with me. Other than that, it's a 0 and you're not taking it. You have plenty of opportunities to get it done. We need to get it made up. I have posted the test review. It is there for you guys to start working on. It's not due until the day of the test on Monday. So my plan is to do 8.3 today, and then in class tomorrow, let you guys work on the homework for this, to let you guys start working on the review. And then Wednesday and Thursday, I know our classes are shortened, but you'll have plenty of time to ask questions over the review. You should work on it at home and then come to me and say, hey, how do you do this? Can you help me with that? That sort of a thing. You do have a long weekend. You guys are off Friday, Saturday, and Sunday. So you're coming in off a 3-day weekend to take a test. So just make sure you guys are aware of that, okay? Everybody with me? All right, thank you. 8.3, guys. 8.3, 8.3, 8.3. We talked last week. Anybody remember what kind of sequences we talked about last week? Arithmetic, however you want to say it. Either way is fine. What is an arithmetic sequence? An arithmetic sequence is a linear function. It has something called a common difference where you add or subtract to get from one number to the next. So today we're going to talk about geometric. This is when you multiply to get from one number to the next. So a geometric sequence, you multiply. What's going on with my iPad? Hang on. M-U-L-T-I. You multiply to get from one term to the next. Always multiplying. And it's called a common ratio. It's not called a common difference. It's called the common ratio. So we're going to talk about how to write the rule and find a specific term, that sort of a thing. But the first thing we're going to talk about is how to figure out if something is geometric or not. It's if you multiply to get from one term to the next. Sometimes with adding and subtracting, it's easier. We can kind of see it. In order to figure out if something is geometric, the best thing to do is to take one term and divide it by the one in front of it. So in letter A, I'm going to take the second term, which is 12, and divide it by 6. What do I get? 2, okay. So then I'm going to take the third term, 20, and divide it by the one in front of it, 12. Is 20 divided by 12 6? No. So is this a geometric sequence? No. It has to be constant. It has to be that you multiply the same number every time. Take another one. Take 42 and divide it by 30. What's 42 divided by 30? It's not 6, is it? So then this isn't geometric. So you guys wouldn't be able to write a rule for this. What about B? All right, let's look at B. What do you notice first about the numbers in B? Are they getting bigger or are they getting smaller? They're getting smaller. Usually, guys, when numbers get smaller and you're multiplying, it's the same thing as dividing. If I was going to divide something by 2, it's the same as multiplying by what? No, if I divide something by 2, it's the same as multiplying by what number? 1/2, a fraction. You're always going to deal with multiplication. So if your numbers are getting smaller, the values are getting smaller, you're not dividing, you're multiplying by a fraction. So look, take a term, take 64 and divide it by 256. Take any term and divide it by the one in front of it. So 64 divided by 256. What do you guys get? 1/4. You guys are going to get 0.25 if your calculator doesn't do fractions. Understand that 0.25 is the same as 1/4. So let's try another one. Let's take 16 and divide it by the term in front of it. What's 16 divided by 64? 1/4. What's 1 divided by the term in front of it? 1/4. So is this a geometric sequence? Yes, because every single time, what are you doing? You're multiplying by 1/4. So your common ratio here is 1/4. And you would say, yes, this is geometric. Now, one thing I want to bring up, I don't know, might discuss it in the other examples, but let's just say we had the same exact thing, but this one was negative, then positive, then negative, then positive, then negative. What would you multiply by for the signs to alternate? a negative. If you ever have a sequence that's geometric and the signs alternate, then you know that the common ratio is negative, because a negative times a negative is a positive. Then when you multiply a negative, it goes back to negative. So whenever you see the signs alternating like that, your common ratio is going to be negative. It's a good thing to just kind of keep. All right, let's go through these real quick. Tell whether the sequence is geometric. Explain your reasoning. A lot of you were like, how do I explain it? Well, just take a term, like 9, and divide it by 27. What does that become? 1 over 3. Okay, let's make sure it's constant. So let's do it again. What about if I put 3 over 9? What do I get? 1/3. What about if I put 1 over 3? What do I get? 1/3. Is this a geometric ratio or geometric sequence? Yes. What is the ratio? 1/3. You're multiplying each time by 1/3. Some of you are going to say, well, it's dividing by 3. No, in geometric, you're always multiplying. So again, let's go here. Take the second term, divide it by the first. What's 6 divided by 2? 3, okay? So take the third term, 24, divide it by the second. What's 24 divided by 6? 4. As soon as you see, oh wait, it's not the same? What's your answer here? No, you do not have to keep going. It has to be the same every single time. You guys with me? All right. Ooh, what do you guys notice about the signs here? They're alternating. So you know if this is a geometric sequence, you know your common ratio is going to be what kind of a number? Negative. Good. So let's say 2 over negative 1 is negative 2, right? So negative 4 over 2 is negative 2. 8 over negative 4 is negative 2. Is this geometric? Yes. And then what's your common ratio this time? Negative 4. I'm sorry, negative 2. You're right. All right. Good job. So writing a rule. Here is the rule for geometric. All right. For our arithmetic, it was a sub 1 plus n minus 1 times the common difference. In this case, a sub 1 is the first term. R is your, what do you think? It's your common ratio. And then the exponent is the term number minus 1. So if you're looking for the 8th term, you plug it in and say 8 minus 1, so it's really the 7th. That's how you write the geometric formula. It'd be a good idea probably to screenshot that and put it in front of all your questions, because I don't think that we're giving you this formula. I think you're going to get the ones for the sums, but not for writing the basic rule. All right, 88. Whoops. Let's look at some examples here. What are some things, what do we need in order to write a rule? There's 2 things we need. First term, I need a sub 1, and I need what the common ratio is. And then everything else just goes into the formula. So what is the first term that you guys see here? 5, perfect. And then common ratio. How do I find the common ratio? Take a term and divide it by what? The 1 in front of it. So 15 divided by 5 equals 3. So your common ratio is 3. What's 45 divided by 15? 3. What's 135 divided by 45? 3. Doesn't matter where you do it. Just take a term and then divide by the 1 in front of it. So if you're going to write the rule, a sub n equals its first term, which is 5. I like to use parentheses, times, what's your common ratio? 3, and you raise it to the n minus 1 power. That is the rule, guys. That's it. Now, you'll notice when we do this in our calculators that geometric functions, they're exponential. Exponential means there's a variable in the exponent. So they get bigger in a hurry. Your number, when I try to find the 8th term here, is probably going to be a really big number. So just don't be alarmed when you see that in your calculator. So they're asking you here to find a sub 8. So what do they want us to plug in for n? 8. So I say 5 times 3 to the 8 minus 1. So what you guys would show me is you would say 5 times 3 to the what? 7th power. Now, if you put this correctly in your calculator, you're good to go. But what should your calculator do? Because you got to make sure you put it in right. What would you evaluate first here, guys? The parentheses. You'd say 3 to the 7th power times 5. So if you don't know how to put it in your calculator, you could just do it like that. You could say 3 to the 7th power Get a number and then times it by 5. But when you do that, guys, what do you get? What's the 8th term of this sequence? 10,935? Okay, so 10,935. So think about it. Your first term was 5, and then just 7 terms above it, you're at 10,000 already. So when you have a geometric function, your numbers get big in a hurry or they get small in a hurry. It's not like linear. That's like a constant change every time. All right, let's look at the second one. What do you guys notice? First off, what do you notice? Yep, the signs alternate. So you know your common ratio is going to be what kind of a number? Negative. So I know my first term is what? First term is 88. And I find my common ratio by taking one of my terms. I'm going to take 22. And I'm going to divide it by the one in front of it. So 22 divided by negative 44 is what? It's negative what? Negative 1/2. So think about it, guys. Think. Your numbers are getting bigger or smaller? Smaller, going down, right? So you'd be multiplying by a fraction. So we're going to set this up the same way. A sub n equals, what's my first term? 88, parenthesis, what's your common ratio? Negative 1/2, and then I raise it to the n minus 1. There is your rule. So to find the 8th term, a sub 8 equals 88 times negative 1/2 to the 8 minus 1. So this is really 88 times negative 1/2 to the 7th power. Now, depending upon what the directions say, if it doesn't say anything about decimals or anything, decimals are fine. But if the directions say no decimals, then you have to work it out with no decimals. But if you have a question on how to put this in your calculator, let me know. We can work on that over the next few days. But what do you guys get for the 8th term here? All right, negative 11 over 16. Negative 11 over 16, okay. Anybody else get anything different? 0.6875? Yep, perfect. If your question says, what's the answer? Either one of those is fine. If your question says decimals only, this is what you need. If your question says no decimals, then this is what you need. So, yeah, you have to. All right, we're good? I plug in 1. Let's move along. Write the rule. Let's write the rule. I need 2 things. I need my first term, and I need my common ratio. Guys, notice, we're working on geometric. A lot of the times it'll say write the rule for the arithmetic sequence or write the rule for the geometric. So it'll tell you which one to use. If it doesn't, you have to figure out the common ratio or common difference if it's adding or subtracting versus if it's multiplying. So your first term in whichever case would be the first term you see. But then you have to say, okay, if I take 15 and divide by 3, what do I get? 5. What about 75 divided by 15? 5. What about 375? So you know that, oh, this is definitely geometric because I'm multiplying each time. So let's write our rule. A sub n equals my first term times 5 to the n minus 1. And then to find the 9th term on this one, I'm plugging in what number? So 3 times 5 to the 9 minus 1. 3 times 5 to the 8th power. What's your calculator going to do first? 5 to the 8th, good. And then multiply that by 3. So what's my 9th term, guys? 1,171,875. Good. Very good. Questions? Same thing. Yep. All right, so now we're going to talk about finding the sum of a finite. If you guys go to pre-cal or college algebra, you're going to talk about sum of infinite and finite. Today we're just talking about just finite. Finite means it ends. There's an ending point. There's a beginning and an end. All right, so here is the formula. I suggest you take a screenshot of that. What is this? Okay, well, what is a sub 1? This is the first term. What is r? Your common ratio. And n is the number of terms. It's the same thing you needed for the sum of an arithmetic. You needed the common difference. You know how many numbers you were talking about. You needed the first term. Same exact thing. You just have to know how to plug this stuff in. So take a screenshot of it. Put it next to the next problems. So here we go. Notice, guys, this is the same funny Greek letter, sigma, that we had the other day. Right? The funny looking E. What this is really saying is plug in, starting with what number? 1. And then what? 2, 3, 4, 5, 6, 7, 8, 9, 10. And then what do I do to all of those answers? If we're finding the sum, I'd add them together, right? But we're not going to do that. We're going to use the formula. So I have to find first my first term. Well, how do I find the first term? What do I plug in to K? So 4 times 3 to the 1 minus 1 power. Doesn't always work out like this, guys, so I just want you to pay attention. If I simplify this, I have 4 times 3 to the 0 power. What is anything to the 0 power? 1. So what is the first term of this sequence, of this series? It's 4. All right? It doesn't always work out that it's just the number in the front. You have to plug in whatever that bottom limit is. You have to plug it in to the formula to find the first term. So what else do I need? I have my first term. What else do I need? Say it again. Well, what's the R? How do I know what the R is? What's the common ratio? What are you multiplying by every single time? What's the number in the parenthesis? 3. Okay, your common ratio is 3. And then how do I figure out n, the number of terms? In this case, it is 10. But what did I tell you to do with the arithmetic? You have to say top minus bottom plus 1. In this case, it is 10 terms. But if this number down here is not 1, then you can't just say it's whatever the top number is. Say the bottom number was 0. They wanted me to start with 0. How many term numbers are we talking about? If I start with 0 and end at 10. What's 10 minus 0 plus 1? 10 minus 0 is 10 plus 1 is 11. So you have to make sure that you just account for all. If it starts with 1, then it's whatever the top number is. But if it doesn't start with 1, if it starts with 7 or 0 or something, you have to say top minus bottom plus 1. So I have all of the stuff I need. So now I have to plug it into my formula, which is right here. So a sub 1, my first term is 4. Then I have 1 minus, what's my r value? 3, and I raise it to the what power? 10th power, over 1 minus, what's my r value? 3. You guys cannot do all of that in your calculator. Maybe one or two of you can get it correctly with all the parentheses and stuff like that, but it's not as easy as it appears. So I would take the time to simplify step by step. The first thing I would do is I'd say 4 times 1 minus. What is 3 to the 10th power? It's a big number. 59,049. You guys get that? 59,049. Over, what's 1 minus 3? What kind of 2? Negative 2. Did you get the same thing or no? Okay. All right, so keep simplifying. Keep that 4 outside. Simplify your numerator. What's 1 minus 59,049? Negative 59048. Okay, divided by negative 2. When I divide these two things, what should I get? What kind of an answer? Positive. Okay, you got to be careful with signs. So I'm going to simplify a little more. Say 4 times 29,524. You guys get that? And then I'm going to multiply that by what? 4. So I get 118,096. You guys get that? So what is that telling me? That's telling me that I started off with 1 and I ended with 10. I plugged in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 into this formula right here, and then I added all the answers together by using that formula. Questions? All right, let's do a couple more. The only tricky part is if you guys have fractions or something like that. So let's talk about what we need. First term, if I plug in 1, I have 5 to the 1 minus 1 power. So in this case, guys, I end up with 5 to the 0. What's the first term of this sequence? 1. A sub 1 equals 1, okay? Well, how many numbers am I talking about? It's top minus bottom plus 1. How many numbers am I talking about? 8, good. And then what's the last thing I need? The common ratio. What is being multiplied every single time? The 5, good. So your R equals 5. So let's plug it all in. My formula is first term, which is 1, times 1 minus the common ratio 5 to the 8th power over 1 minus 5. Now simplify within, guys. Don't try to do everything at one time. I have my 1 outside. 1 minus, what is 5 to the 8th power? $390,625. You guys get that? Okay, so 390,625 over, what's 1 minus 5? -4, perfect. Do I need to put that 1 out front? No. Can I if I want to? Yeah, but you don't have to. So I have 1. Now, what's 1 minus 390,625? Yep, 64, good. Divided by -4. A negative divided by a negative is a positive. So what's the sum of this series? $97,656? Yeah? It's not as difficult as it appears. You just have to take your time. Work through it methodically. Same thing with the next one. All right? What is the first term? I can't just look at it and say, oh, I know for sure. Go ahead and plug in. Whatever this bottom number is, you need to plug in. So 6 times -2 to the 1 minus 1. Guys, what's 1 minus 1? 0. And anything to the 0 power is 1. So your first term is 6. What is your common ratio? What's your common ratio? It's the number in the parentheses with the exponent. It's -2. And then my n, how many numbers am I talking about? Top minus bottom plus 1. 12 minus 1 plus 1. How many numbers? 12. So let's throw it in the formula. First term, 1 minus my R, which is -2 to the 12th power over 1 minus -2. This one's tricky because you have negative signs. Do not change this to a positive right here yet. What do you have to do first? You have to do the exponent first. So this is 6 times 1 minus. What is -12? You have to put the -2. You have to put the -2 in parentheses. If you don't, your calculator will raise -2 to the 12th power, or raise 2 to the 12th power and then multiply it by -1. So put -2 in parentheses and raise it to the 12th power. What'd you guys get? 4,096, good. And then what's 1 minus a -2? Positive what? 1 minus -2 is going to give me positive what? 3, okay? So what's 1 minus 4,096? -4,095, okay? Divide that by 3. Does it divide pretty? God bless. What's negative? Everybody should be doing this in calculator. -4,095 divided by +3. What do you get? Negative or positive? Negative 1,365. And then I multiply that by 6. -8190. There you go. All right, let's do the last one and then we're done. And we're done for everything you guys need for the test. So you can start your homework, you can start the review, whatever you need. The next few days, that's what we're going to be doing in here. So let's talk about this. What is my first term? Well, I have negative 16 times 0.5 to the 1 minus 1. Again, this happens to be 1 minus 1, so 1 minus 1 is what? 0. Anything to the 0 power is 1. So your first term is 16. What is the common ratio? What are you multiplying every single time by? I didn't put the negative right there. You're right. Sorry. Negative right there. Thanks. What are we multiplying by? What's the common ratio? What's in the parentheses with the exponent? 0.5, right? 0.5 is also the same as what fraction? 1/2, okay? And then how many numbers are we talking about? 7 minus 1 plus 1, so a total of 7 numbers, right? Excuse me. So first term is negative 16 times 1 minus 0.5 to the 7th power over 1 minus 0.5. Everybody agree? Did I write it correctly? So negative 16, let's simplify within. Let's go ahead and say 0.5 to the 7th power. Whoa, what do you guys get? Okay, so 0.0078125, God bless, over, what's 1 minus 0.5? One minus 0.5. Do it in your calculator. All right, so let's keep simplifying. Negative 16, and then my numerator, I have 1. Be careful when you put this in your calculator. Make sure you get all your zeros and stuff right. 0.0078125. What do you guys get? Point what? 992185. Divided by 0.5. Okay, that's okay. That's fine. So go ahead and divide that by 0.5. What did you guys get? 0.992185 divided by 0.5. 1.984375. Okay, fine. And then what's the final thing I do? Times that by negative 16. What'd you guys get? 31.7, negative 31.75? Yep. So don't be alarmed by the size of the numbers, whether they're really big or really small. One thing I will caution you, you should not get scientific notation in your calculator. If it's like the display says like 1.33 and then with e's and stuff to it, then you missed something, a decimal or something. But you guys have 8.3 homework. It's due on Wednesday. So yes, you'll have time in class to work on it tomorrow. I wouldn't just wait. Try to work some of it out. So if you have questions tonight, you can ask me. And then the review is also posted. So if you have questions, you can look over it, but we will go over that as well. Sound good?